Welcome guys. Today we'll be doing trigonometry identities. Let's look at this proof that we need to prove the left hand side is the same as the right hand side. Now first I'm going to look at the denominator. We have some identity for the denominator. So cot A plus tan A on the left hand side has lots of information where I can work with the left hand side to prove that it's equal to the right hand side. Now we can recall the identity for cot A. Cot A is the same thing as cos A over sine A. So all I'm doing is replacing it with the identity. We also know that the identity for tan A is sine A over cos A. Now, what we're going to do now, because these are two fractions, we're going to find the LCM. So the LCM of sine A and cos A, I'll write in the denominator, it's sine A cos A. Now, just like when you have fractions, you say sine A into the denominator, the two sine A cancels, so we're left with just cos A. So we multiply cos A by the cos A in the numerator that we have here, and it gives us cos square A. Plus cos A in the denominator, the cos A cancels, so we're left with sine A, and sine A multiplied by sine A gives us sine square A. Now the identity is that cos square A plus sine square A is 1. So we're left with just 1 over sine A cos A. So this information that we have here, it is the denominator of the left hand side being simplified. So now I'm going to replace the denominator with the information that I have just gathered here. So I'll rewrite the numerator for the left hand side is cosec A, and replace the denominator to be 1 over sine A times cos A. Now cosec A is in the numerator and 1 over sine A cos A is in the denominator. Now I can write this fraction in terms of having cosec A, then having the slash which separates numerator and denominator to rewrite it as division, then I have the fraction 1 over sine A times cos A. Now cosec A is an identity, and I can rewrite cosec A as 1 over sine A. I'm changing that as multiplication, then reciprocate the fraction, so it becomes just sine A times cos A. And you could leave it like this or write it as over 1 because maybe you want to show that, okay, I flipped it. Now the sine A cancels, so all we're left with is cos A. And that is it. As you can see, we have proven that the left hand side is equal to the right hand side. Now let us look at the next example where we're going to prove that 1 over sine A minus 1 over tan A is the same thing as 1 over cos A minus sine A. Now, doing this example, let me rewrite the 1 over sine A, but we can go ahead and change tan A, since we already know that tan A is sine A over cos A. So rewriting this, it will become 1 over sine A over cos A. Now, when I'm proving trig identities, I usually use the left-hand side because 3/4 of the times, majority of the information is on the left-hand side to prove that it's the same as the right. Now, we also know that when we have a fraction in the denominator, we can reciprocate it, and some persons like to say flip. So flip it so it becomes cos A over sine A. Now, doing this, we are now going to add, and since the denominator is the same, we can leave the denominator as is. So I write it 1, so you have sine A, and then in the numerator, I'll just have 1 minus cos A. Now, just in case if somebody is still not understanding, how is it that I did this? Just think of numbers when you're doing these LCM in trigs. If I have 1 over 5 minus 4 over 5, we know when we're using numbers, we leave the denominator as is. So I'll have the 5 in the denominator, then I'll say 1 minus 4. The same case here that we did where we just say 1 minus cos A, and the numerator I have 1 minus cos A, which is the same as saying 1 minus 4. We have now proven that the left hand side is the same as the right hand side. Our final example, we have 1 plus sine A over 1 minus sine A, and we need to prove that it's equal to tan A plus sec A all square. Now I'm still going to stick to the left hand side, and I'm going to multiply the numerator and the denominator by 1 plus sine A. Now I'm thinking of it as rationalization for those who know how to rationalize. But the main reason I don't have a denominator on the right hand side, so that's why I'm trying to get rid of the denominator that we have on the left hand side. So I multiply by the opposite sign, which is 1 plus sine A. Now 1 times 1 is 1 in the numerator, then we multiply 1 times sine A, that's sine A. Then we multiply sine A times 1, that's sine A. Then sine A times sine A, that gives us positive sine square A. Now in the denominator, we're going to realize eventually that things are going to cancel. So expanding, 1 times 1 is 1. 1 times sine A gives you positive sine A. Minus sine A times 1, that's minus sine A. Then minus sine A times positive sine A gives you minus sine square A. Now in the denominator, the sine A's cancel, positive minus the negative, that's 0, so that's cancelled. We can go ahead and simplify further in the numerator, where we have sine A plus sine A, that's 2 sine A. And then rewrite everything else in the numerator as is, so we'll have the plus sine square A In the denominator, what is left is just 1 minus sine square a. Then for the denominator, 1 minus sine square a is an identity, so I can rewrite 1 minus sine square a as cos square a. So I'll be rewriting the numerator. So we have 1 plus 2 sine a plus sine square a. Now the next step for me is to split this into 3 different fractions. So we have 1 over cos square a plus 2 sine a over cos square a plus sine square a over cos square a. Now we are going to write the individual identities for each. So 1 over cos square a is the same thing as sec square a. The next part, we can split the denominator. So we have 2 fractions being multiplied. So we have 2, then sine a over cos a times 1 over cos a. So sine a over cos a times 1 over cos a gives us sine a over cos square a. Now sine square over cos square a is the same thing as tan square a. And rewrite the sec square a. Then the center, we can replace it with a trig identity. So we have sine a over cos a is the same thing as tan a. And 1 over cos a is the same thing as sec a. Now rewriting the plus tan square a. Now this represents expansion of tan a plus sec a all square. So we can rewrite this expansion, that's the expansion line, to be open bracket tan a plus sec a all square. And that is it. Now, some persons like to expand the right hand side to get an ideal. So let me rewrite tan a plus sec a all square as tan a plus sec a times tan a plus sec a. Now expanding this bracket, what we have is tan a times tan a, that gives us tan square a. Then we have tan a times sec a, that's tan a sec a. Then sec a times tan a, that gives us sec a tan a. And then sec a times sec a gives us sec square a. We realize the center is the same, so we can go ahead and add to get 2 tan a sec a. And as you can see, it's the same result as what I was explaining, that the second to last line is the expansion of tan a plus sec a all square. Thanks for watching, guys, and don't forget to subscribe to my channel.